Welcome, math lovers, to another video of our channel. Today we will go to Ecuador for the Ecuadorian Math Olympiad of 2021, and we will present a problem from the final stage of high school Olympiads. Uh, in this problem, for me it's very important to mention the fact that all these problems we are presenting in this channel are genuine mathematical competitions problem and are not titles that we make only for make sensational videos or titles in order to attract more views, because the channel has been open only for pure mathematics love, and what we are trying to do in this channel is to present uh, beautiful solutions, elegant solutions for these problems that we present from Olympiads around the world that do not require any special knowledge of advanced techniques in mathematics. So, for this Ecuador Math Olympiad of 2021, the request of the problem is as follows. Find all integers n such that 4n divided by n squared plus 3 is an integer. So, as always, if you want to present a solution to this problem, pause the videos and please take time to make a comment above this video. So, for the solution of this problem, as always, as like our channel does, we have covered the solution in order to go through it step by step together. So, first of all, to solve this problem, we need to set some boundaries on the value n can take, and we have to be very careful in this problem because the problem requires all number n from the set of whole numbers, not only numbers n from the set of natural numbers. So we have to be very careful when we do our considerations of this problem, and in order that if you are a contestant in a contest, to not lose any points or any possible solution of the problem. So we know that in order for the number 4n divided by n squared plus 3 to be an integer, their division should also be an integer. So we should have that. Be careful over here. The absolute value of the expression 4n divided by n squared plus 3 should be greater or equal than 1 in order to have, let's say, all the possible solutions of this problem. So we go forward. Given that n squared plus 3 is always a positive number, this means that the absolute value of n squared plus 3 is equal to n squared plus 3, because as we said, this expression only takes positive values. So inequality number 1 that we have expressed over here becomes absolute value of 4n divided by n squared plus 3 is smaller or equal to 1. We call this the inequality number 2. We now expand the inequality number 2 in order to have that absolute value of 4n is greater or equal to n squared plus 3, which brings that n squared minus the absolute value of 4n plus 3 is smaller or equal to 0. So we add plus 1 to both sides of this inequality in order to complete the square on the left-hand side, and we will have that n squared minus absolute value of 4n plus 4 is smaller or equal to 1. And by making the square, we'll have that absolute value of n minus 2 all squared is smaller or equal to 1. We call this the inequality number 3 of our problem. Then we take the square roots of both sides of the inequality 3 in order to have that the absolute value of this square over here is smaller or equal to 1. So absolute value of the absolute value of n minus 2 is smaller or equal to 1, which would bring that absolute value of n minus 2 is greater or equal to 1 and smaller or equal to 1 on the other side. So this is the boundaries of the absolute value of this expression over here, or in other expression, adding 2 to all sides of this inequality on two sides, we will have that absolute value of n is greater or equal than 1 and absolute value of n is smaller or equal to 3. So this means that n itself is greater or equal than minus 3 and smaller or equal to 3 in order to fulfill the conditions of this inequality over here, and we will call this the inequality number 4. So the inequality number 4 is fulfilled for the whole values of n, which are -3, -2, -1, 0, 1, 2, and 3. However, we should verify that these values for which the expression 4n divided by n squared plus 3 is an integer. So, by direct substitution and proof, we have that 4n divided by n squared plus 3 is an integer only for the values of n equal to -3, -1, 0, 1, and 3, because we over here make the substitutions of n minus 3, and we have the result is -1, which is an integer. For n minus 2, the result is -8 divided by 7, which is not a whole number, and n minus 1 gives -1 as a result, which is an integer. N equal to 0 gives 0, which is an integer, which is part of the whole number set. N equal to 1 is an integer, n equal to 2 is not an integer, so it is not a solution, and n is equal to 3 is an integer, which gives another solution. So at the end of this problem, we say that the only possible solutions for which the expression 4n divided by n squared plus 3 is an integer are only the values of n equal to -3, -1, 0, 1, and 3. So thank you for following us in our video. As always, like, comment, and subscribe if you like the video or if you have an alternative solution, and see you on our next videos from the channel Solutions from the Book. Up to then, goodbye.